Hello everyone. In this video, we are going to talk about in a little more detail on how snapshot isolation is implemented by the databases. And we are going to look at the technique called MVCC, also known as multi-version concurrency control. And to provide snapshot isolation, multiple versions of your object have to be maintained by the database in order to provide a consistent snapshot for your reads. Every transaction, when it starts, it's assigned a transaction ID, which is an auto incremented number, which only goes up. And each version of your object will have a created by field and a deleted by field, along with the other uh, fields that you have defined for for the table. And the created by field has the transaction ID of that transaction ID that inserted that row, and the deleted by field will have the transaction ID that deleted that row, and it's a soft delete. And if a transaction deletes a row, the row isn't actually deleted, but it's marked for deletion, which is later picked up by a process similar to garbage collection that removes any rows that are marked for deletion and frees up their space. Let's look at this example. You have two accounts, account 1 and 2, and you have transaction ID 12 that started, and it read the balance from that account and it got 500. And this transaction ID 12 haven't made any updates, so there is no new version created for that object. And you started another transaction, transaction 13, which is updating the balance and incrementing it by 100. And when that update happens, you will see a new version of that object. So you have the created by as 13 and the deleted by is null, and the balance is now 600. And when you have the next update where you are updating account 2, you are decrementing the balance by 100, and it will have a new version of that account 2 which says created by 13, deleted by null, and the balance is 400. Now, if the first transaction which started earlier, which is transaction 12, and when it does the read from account 2, it will only get the transaction, or it will only get the that version of that object that started before transaction ID 12. It will not get any updates made by transaction ID 13 because it hasn't this transaction ID 13 has not started yet when ID 12 started. So it will still get the value of 500, and it then commits. Now, there are some rules which are defined on which transaction IDs are used to decide what objects it can see or what versions are visible for other transactions. So at the start of each transaction, the database makes a list of all the other transactions that are in progress, so which are not committed or aborted at the time. And any of those transactions that are ignored, any transactions are ignored if they start at a later time, even if they have committed. And any writes made by aborted transactions are ignored, and any writes made by transactions with a later transaction ID are also ignored, even if they are committed. And all the other writes are visible for the application's queries. This way, you will get a consistent snapshot whenever you want to read. And we will look at the next topic in the next video. Thank you.